All right. Hello, everyone. I'm Matt Moore, and today we're going to be talking about Distroless Docker and containerizing apps instead of your VMs. I wanted to lead with a little bit about who I am. I am Matt Moore. I am a Google staff software engineer. And I'm passionate about developer tools. I'm passionate about containers. And I've been involved with Docker at Google since there was a Docker at Google. I helped build the container registry team. I was the original TL there. And these days, I am sort of an Uber TL of container development stuff. And one of the things that I've been in pursuit of for years now is a better way of building containers. In a former life, I was a compiler engineer, and that's going to bleed through a little bit in this talk, so I figured I'd warn you. So I wanted to lead with sort of a TLDR of the talk. We're going to talk about how a lot of what goes into containers today really isn't necessary. And this probably isn't news. Bigger images have higher cost. They're slower to download, slower to upload. And that reduces your development cycle speed. It creates a larger scope for compliance stuff, more stuff to CVE scan, more stuff to track the provenance of, et cetera, et cetera, et cetera. So Distroless, I see it as about trying to achieve something as close as possible to from-scratch containers for the things that you can't just throw in a Scratch container. Scratch container being empty container, I statically link my Go or C++ binary, I stick it in there. That's as minimal as it gets, right? This is essentially how Google deploys software in production. And we're going to demo this today with Basil, Google's open source build system. But I also wanted to demo this with Dockerfile to show it's not just a Basil thing. So this is structured to sort of take us on a journey that talks about sort of how we arrived at the state of the art of Docker files today. And in the beginning, before there was Docker, everyone was using VMs in cloud, right? And a lot of stuff runs on VMs. You have a lot of daemons, you've got stuff that keeps stuff running, you've got stuff that runs stuff periodically, you've got stuff that rotates your logs, stuff that allows you to connect to the node and debug what's going on, as well as fill in your favorite agent for collecting metrics about what's going on, health of your software, et cetera. You've also got an assortment of libraries and utilities, and all of this is ultimately just in support of running your service, which is the most important thing on that VM. So enter Docker, right? Docker enters the picture, and Docker was trying to figure out, as a lot of people who were exploring the use of Linux containers in production, how to effectively package your app and run it inside of that isolated Linux container tree. And so the challenge was, how do I bundle up an app and all of its dependencies to run in an isolated environment? So we come up with our solution. So Docker came up with I think that in certain respects, this is an incredibly elegant solution. They identified that, hey, that VM's file system was sufficient to run my service. Let's just stick all of that in the tree. As a former compiler guy, I told you I was going to leak through, I like to think of this as statically linking your app at the distro level as opposed to the language level. And I think that part of the elegance of this solution was that it took the world of containers and it opened it up to a huge class of folks who were used to bootstrapping VMs. And you could now bootstrap your container environment in much the same way as you bootstrapped your VM file system. And I think that this helped solve their empty restaurant problem with Docker Hub, et cetera. It allowed them to bootstrap the ecosystem very rapidly. with this familiarity. But a former colleague of mine was not wrong when he described this as an elegant hack. So why, right? Well, the VM's file system was sufficient, but it's complete overkill. It is way more than is actually necessary, right? And we have a new problem. We don't want poor little Moby to drown under the crushing weight of everything you're putting in your containers, right? And so, of course, for this new problem, we find ourselves a new solution. This started with starting to throw stuff out of the early Ubuntu and Debian images, which were over 100 megs. But then we sort of hit a wall, right? As I understand it, to qualify as a Debian distribution, you have to have all of the required packages. And according to the Debian manual, systems with only the required packages are probably unusable, but they do have enough functionality to allow a sysadmin to boot and install more software. Well, in my container, at runtime, how many of you install more software when you get API requests, right? Okay, that's what I thought. Okay, so we hit this barrier with what's required for Debian and Ubuntu, and we arrive at our ultimate solution, which is smaller distros. We basically found distros that had much smaller requirements about what was actually required to qualify as that distro. And what we found was things like Alpine, right? Alpine's effectively BusyBox and a package manager with a muscle libc. Now, BusyBox, the origins of BusyBox is basically exactly what I just described the Debian manual is describing for required packages. It was intended for effectively bootstrapping and poking around at an embedded system, right? Which is why it's so good and so small, right? But I specifically mentioned it uses muscle libc, right? And so in our pursuit of small, we've sort of compromised on compatibility, right? So smaller distros. So I'm going to invoke Henry Ford on smaller distros. Henry Ford famously said, if I had asked people what they'd wanted, they would have said faster horses. In our case, smaller distros. And so we've been pursuing faster horses, right? And with some of the compromises we made in terms of compatibility along the way, it's sort of like we've invented a faster horse that's not compatible with my butt. It won't take me from point A to point B faster. And so we need to ask ourselves the question Henry Ford asked himself. What were we actually trying to do? In Henry Ford's case, people were trying to get from point A to point B faster, right? The horse was an implementation detail of that, right? Car, suitable replacement. So we were just trying to run our app in an isolated environment. So instead of taking the approach of what's sufficient and trimming it down, let's take a, do you guys see my screensaver? Excuse me. All right. I thought the clicking would avoid that. Maybe I'll have to wave my hand as well. We were just trying to run our app. So let's look at what's necessary to run our app instead of starting with sufficient and trimming it down. My app typically needs my compiled source if it's a compiled language, otherwise the source if it's an interpreted language. Some set of dependencies, pip packages, jars, whatever libraries I'm using. Assets I'm going to serve, as well as the language environment that all of those things expect in order to operate. So if it's a Java dialect, JRE language, you need a JRE. If it's Node, you need Node. If it's Python, you need a Python interpreter. If it's a compiled language like Go or C++, you probably need something like libc. So basically, what we just described was everything that happens between your high-level app and all the calls that are made until you reach, effectively, the kernel syscall interface, right? And why is that? Well, VMs are instruction set level virtualization. That's your interface for the virtualization. Containers are all about process level virtualization, right? And the process boundary is the kernel syscall interface, right? And so what's necessary for us is everything between the app and the kernel. And so it turns out my build tool knows all of that, right? When I'm compiling my code, I know what the target runtime environment is, right? If I'm building Go code, right, I know what architecture I'm targeting and what the runtime requirements are in terms of the libraries that are available on that system. I know I'm either statically linking, I need nothing from scratch, or I'm targeting a system that will have some sort of libc. For Java, I know I'm targeting the JRE, and you can substitute build with packaging system for languages that don't typically have build, right? So, all right. So imagine if the tool chain that you were using was paired with effectively a base runtime image that was effectively a reference implementation for the environment it's targeting, right? I'm targeting, I'm building my Java code, my jar with JDK 8. Suppose it came with a JRE 8 image that was a stripped down version of exactly what you were building for. Well, OK, that's what Distroless is. So let's see a demo of it with Docker build. But first, what the heck is Docker build? Docker builds, I would characterize it as an implementation of this idea. It's one way of consuming this, right? It's a set of rules for the open source Basil build tool. Let's walk through the elements of what you would use to declare or to consume this. So in Basil, there's this concept of a workspace file. Your workspace is where you declare all of your external dependencies. In this case, I'm going to say, hey, I'm going to build a Java app. I need a Distroless Java image. So I'm going to pull down the Distroless base. And then in my build, I'm going to build a Java binary. And I'm going to package it up into a Docker container. That Docker container is based on my Distroless Java base. And I'm including my app that I built, the jar I built, into that Docker image. OK, so let's see this in action. Right. OK, so can everyone see this? It's a git diff. Yeah? OK, great. So I've taken, I've hijacked the App Engine Flexible Environment Hello World sample. It is just a trivial little Java servlet that serves Hello World. I've, in standard conference style, replaced world with swampUP. So let's take a look at those elements that I called out on the slide. In this case, I've switched from a pure Java JRE container to a Jetty container, because what we're going to build is a web app. And you can see down here at the bottom, Docker pull, Jetty, Distroless, Java, Jetty. And if we look at the build file, there are 3 rules here. There's a Java war rule for building my web archive. There is a build rule, a Docker build rule, which overlays that war under Jetty web apps and puts that on top of the Jetty base. And then a third rule, which actually, it wasn't on my slide, but it allows me to publish this using Basil. OK, so without further ado, I'm going to run the push rule. So this is downloading my, I was practicing this morning, and this didn't work because my Wi-Fi had cut out, and it freaked me out. This is pulling down the Distroless base, building my war file, overlaying it on top of the Docker image, pushing it up to a container registry. And you can see it's done. So now I'm going to show it running. But I can't do that on my MacBook, because I did all of that without Docker installed. Special. So I've got a Linux VM here. I'm going to clean it so you know that there are no, I didn't preload it. There's no, this is live demo, no ready-made chicken coming out of the oven. So let's pull down swampUP latest. and kick it off. Docker, sorry, this mic's in my way. All right. All right, so you can see here Jetty starting up. I'm going to switch back to my browser. And we had modified hello world to say hello swampUP. Right? So I've effectively done a full cycle of Docker development. And you can imagine me switching to my Linux VM with replacing it with, from my MacBook, doing a kubectl update of my cluster, right, to deploy this new thing to a new environment, right? But I need the VM handy for my next demo. So, OK, so I'm going to kill that. Let's go back to the slides. OK, so let's see. OK, so I wanted to talk a little bit about Docker build at Google. And I put together a slide with this impressive list of teams throughout Google that are using this, because this has been around inside Google for a couple of years now. And I had this slide ready, and I was like, what do I need to do to get approval for this? I sent mail to my boss and my director, and they sent me a link to the process, and I clicked on it, and I was like, nope, 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 nope. So suffice it to say, there are dozens of us, there are dozens of teams at Google using this today in some capacity in production. OK, so why did I start with demoing this with Basil? Well, you may know, probably because we won't shut up about it, that Google has been doing containers for a really long time. And Basil, really what we call Blaze internally, is central to that. It solves this static linking problem for us, right? Docker solved it by statically linking at the distro level. We solve it by statically linking at the language level, right? So for languages that compile to static binaries, we compile to static binaries. For languages that target the JRE, we produce what we call deploy jars. For Python, we have Python archive files, PAR files, and we even have, and I wish I was kidding, SAR files. And so combined with the fact that this, some of the ideas behind creating these distroless runtimes come from how we run software, run this statically linked software in production, Basil provided this nice foundation for showcasing this. And just because we kind of live in a glass house, these are our elegant hacks. So Basil has many advantages. I have drunk the Kool-Aid. But it is not intended to be the focus of this talk, so I'm happy to instill the virtues of it if you come see me afterwards. But as I was starting to organize my thoughts on sort of, like I said, I'm in pursuit of a better way of building containers, and I had started to organize my thoughts around this, and I had this concept of Distroless mixed in with a whole bunch of other benefits from doing these builds with Basil. And one of the pieces of feedback I got, which I took to heart when I was preparing this, was that Kelsey Hightower had indicated that I bait and switched him with Basil. He was like, you promised me this glorious promised land, and then you were like, oh, but I'm going to switch my build tool. So Distroless, for a lot of the benefits, you do have to use Basil. But to make it abundantly clear that for this, what's the focus of this talk, for Distroless runtime images, that you don't need Basil, I wanted to demo it with a Docker file. So what does it look like to use this with a Docker file? After all, I promised from scratch for the rest of us, right? So the Docker file is actually very simple. You basically download the runtime app, or the runtime base that you want to overlay your app on. You stick your statically linked at the language level jar or whatever inside of it, and then you just tell the JRE to run it. You know, the Jetty version, actually, which we'll see on the next slide. A little different, but so a couple months ago at DockerCon, they actually, oh, I missed one click, where the jar obviously comes from, excuse me, Maven or Gradle. So, all right. So a couple of months ago at DockerCon, Docker actually did me a favor. It made it easier to demo this with Dockerfile by introducing multi-stage builds. So with Docker 17.05 and later, you can actually bake your Maven build or whatever right into the Dockerfile, right? And still get a Distroless base. You can basically say, hey, do a Maven build, copy in my workspace, run Maven package, and then when you're done, take the war that comes out, put it under Jetty Web Apps in a Jetty container. Excuse me. All right, so let's see this in action now. Oops, switch. All right, so, let's switch back to that Linux VM. And this one doesn't have the hello swampUP modification so that we can see it change when we refresh the page. But I cleaned the VM. So it has to download the Maven container. Then it's going to invoke the excuse me, the Maven build. Clean Maven build, downloads the world. But once it's downloaded all of this stuff, packaged up the war, we're going to grab the Jetty image, as you can see here, and overlay the war on that base. And I had just called it swampUP, so I can now run just swampUP. And if I switch back over here and I refresh the page, I've got hello world. All right. So, killed the web app. Come over here. All right. OK, so let's quickly recap. All right, so we went on a bit of a journey and talked about sort of how we arrived at the state of the art with Dockerfile, how we started with this world of the sufficient file system derived from what we put on VMs, and we ultimately pursued that to smaller and smaller distros until we went to the sort of hyper extreme of small with things like Alpine, which start to compromise on compatibility. And we then re-examined our goal. Right? Our goal is really just to run our app in a compatible environment. And we showed that. And we did a demo of it with both Google's build tool, Basil, as well as with Docker files. So I wanted to talk a bit about the state of these runtimes. So within Google, we have a variety of teams that sort of maintain our language environments for production and what we put inside of our containers to roots. So when it came time to construct Distroless runtimes for our use internally, by the dozens of internal teams I mentioned, it was really just a matter of packaging up that same stuff in a Docker image. So it was very convenient. But in order to externalize that and make that available to you guys, we don't have those teams, really, at least not in the same way. And so I would characterize these runtimes as somewhat early days, but what we've chosen to do is replace those teams with basically the Debian maintainers, who, in a sense, curate a JRE, et cetera, et cetera, et cetera. And so what we're doing is we're sort of disregarding the Debian definition of required, and we are curating runtimes by selectively expanding the file system elements of Debs into a Docker or root. Why did we choose Deb, right? We could have chosen muscle libc and done with APK what we did with Deb, and we would have been guaranteed to be smaller, because what we would have ended up with is exactly your Alpine container, just deleting the elements you don't need. But we wanted to start from a place of strong compatibility with glibc, et cetera. OK, so language support. This has grown as recently as last night. We have a fair number of runtimes published to the Google Container Registry right now. The base works with Go apps. We've got a C++ base that is usable by C++ apps, Rust apps, D apps. We've got a Java base and a Jetty base that you can use with J or E languages. We've also got a Python 2.7 base and a Node base. So with that, I will sort of insert the plea for engagement and help from the community, right? Like, if you guys want to try this out, file GitHub issues. I'll put up the links in a second. Send us your feature requests. And if you want to get involved in shaping what I believe is the future of how we run containers in production, excuse me, send us pull requests. So before I open it up for questions, I have no idea how I'm doing on time. Good? All right. I wanted to put out a special thanks to Dan Lawrence and Matt Rickman, who have largely been driving some of the creation of these Distroless runtimes. Without them, I probably would not have the demos I have today. OK, so questions. While I answer questions, I'm going to put up a wall of links. So fire away. Or don't. I'm sure I answered all of you. OK.
If you're doing Distroless Node and you have a node, if you're doing a Distroless Node application and you have a module that requires external dependencies, how do you make sure those get into the distro?
That's a good question. So actually, Node's actually a perfect example to talk about this because, sorry. Node's a perfect example to talk about this because the thing that really inspired me to incorporate multi-stage builds into the demo, there was a CodeFresh blog post shortly after DockerCon that talked about basically using multi-stage builds to install your Node modules in one container and then copy the installed Node modules into your runtime container, right? And they were doing it into something like Alpine, but you can do something like that with these as well. Does that make sense? So there isn't a really good, we don't have a nar file coming out of Basil yet, but I hope we can get the Node folks to create a nar file for us. That would be kind of funny. Right. Yeah. So with the par file, basically the way it works is coming out of Basil, you would declare your Python dependencies in your workspace. And then when you build your Python binary, it can produce a par file, which bundles all of that stuff into a single archive. Sort of like a jar, including all of its transitive dependency jars. Sorry, I apologize. Talking is exacerbating it.
I have a question. So, do I understand correctly that you use Distroless for both building and running the application?
No. We don't use this environment for building the containers because you can't really run anything else in the containers, right? There's no shell, for instance. The entire point is it's stripped down to almost exactly what your app will need at runtime. And so you can think of the construction process of these containers. What Basil's doing, right? I said that there was no Docker daemon on my MacBook. You can think of it as cross-compilation of Docker images, right? And so we're effectively constructing everything we need for the target environment, but we don't execute it inside of it. And so with the multi-stage builds, right, you would execute in an environment that was capable of doing your build. You can think of it as the distinction between your JDK and your JRE, right? You don't have the full development environment in your runtime environment, right? You need some additional tooling. Does that make sense?
Yes, thanks. So second question. If I want to create this Distroless myself, and I am in team that creates some like base images, and for example, our company has Kerberos, so there needs to be Kerberos every time. So how do you install that if you don't have a distro? And for example, CA certificates and other stuff that, well, if you connect to SSL, you need to,
sure.
SSL, like things like that.
Excuse me. So you can, all of the construction of these images is on GitHub under Google Cloud Platform/Distroless. You can see how we're doing it. Some devs are tricky because they have post-install hooks and they don't cross-compile, to abuse that term. They don't cross-compile easily. And so we do some custom stuff, but we do have CA certs in our base image. I'm not sure offhand what Kerberos would take, but you can look at how we're expanding the devs today on GitHub.
So question, for when you're actually running these and you have scaling events, are you, since you're using Distroless, are you building the entire image every time you have to scale? Or are you storing, after you've already built this, into a distro so it's already pre-baked for all your running purposes?
So once the Distroless image is baked, you would store it in a container registry and use it just like any other container image, right? The only capacity in which you really need a distro at all anymore is for your the host OS on your node that's actually running Docker and whatever other daemons, right? The VM that you're running your containers on, so to speak, needs a distro, right? You know, you don't run a distro at all in your container anymore. Does that make sense?
Yes, thank you.
All right. Thank you, guys. Been a great audience. If you want, thank you.